उसको बड़े अच्छे से ब्रश अप करेंगे। एट द सेम टाइम
Sir, we are live.
हमारे ये भी बताएंगे कि कैसे क्वेश्चन
Okay, hello students. Good morning everyone. Welcome to the GATE Academy. Welcome once again in the next section, in the second section of engineering mechanics. Okay, yesterday we have taken the first section and we have seen some questions from statics portion. Basically, we have seen 4 questions and covered lots of topics. I think last session was helpful to you, and today you will be learning so many things once again. You will be revising so many things once again. Okay, so let me once again tell you what this session is all about. This session is all about revising the complete syllabus, using questions. Okay, with the help of questions we are revising complete syllabus. With the help of questions we are revising the concepts behind those questions, considering we will be dealing here with the questions which will appears to be subjective type but will also include all the concepts. Okay, so hope these questions will be helpful to you and most of the important parts will be covered. Whoever will join, please. Good morning Vijay, good morning Harsha, good morning Vijay. Okay, so today we will start with one question. Just watch here. This is the question. A particle is projected with a speed u and an angle theta with the horizontal. Consider a small part of its path near the highest point and take it approximately to be a circular arc. What is the radius of the circle? A similar type of question was asked well before 2000. Okay, in 1997, 1998, such type of question was asked, but right now because they have removed some part and they have added some part, we can consider that okay, again these type of questions can be asked. What are the concepts which are present in these questions is you have to have the concept of circular motion as well as you have to have the concept of projectile motion. Both the concepts when you will be having, only then you will be able to do the question of this type. Okay, now before starting, since we haven't kept any question from linear motion directly, so just before starting this I would like to go for the revision of linear motion first and then we will start with this. First of all we are going, whoever will join, please comment in chat box. Okay, so first of all we are going for the revision of linear motion and then we will watch that how to approach such type of question. Now the question is for linear motion you should understand that okay Athil is also here. For linear motion, right now we are just watching or revising the concept of linear motion. In linear motion, what we have to understand is there are few relations which we all know. V is equal to ds by dt, A is equal to dv by dt, A is equal to v dv by ds, A is equal to del 2s by del t square. So these are the relations which we must keep in mind. Okay, say general, always applicable. These relations are always applicable. There is no any requirement for the cases in order to say that this equation is completely correct. Okay, but say for example, if acceleration is constant, then we have some equations of motion. Those are v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and sn is equal to u plus a by 2 into 2n minus 1. So these are the relations. These are the relations which are useful only when the acceleration of the body in the linear motion is constant. Acceleration of the body in the linear motion is constant. We have seen, if we are going for saying that there is some motion, then the motion can be of two type. One is uniform motion, and another one is accelerated motion. Again, when we see the accelerated motion, there are two types of motion possible. One is uniform acceleration, or you can say that constant acceleration. And another one is acceleration is not constant. So until and unless the acceleration is constant, you can apply these equations. But if acceleration is not constant, you cannot apply this equation. Then again you have to go for the basic relations which we have arrived to using the basic definition of velocity and acceleration. Okay, am I clear about up till now? So these are few points which we should keep in mind whenever we are dealing with the question of motions. Okay, now we have gone to the revision of linear motion. Whatever the important points were there, we have mentioned it over here. Now the question, let's move to the question. A particle is projected with a speed u at an angle theta with the horizontal. So first of all, you should understand that in a projectile motion, what are the points which you must keep in mind or you must remember basically in order to solve the question. The relation are maximum height. Now we are talking about projectile motion. Three relations should be there with you all the time. That you should memorize basically. Maximum height, total time of flight, and last point is range, or you can say horizontal range. So what are the values of range, total time, and maximum height? We have seen that how these formulas came. Time is equal to u sin theta by g. Time is equal to 2u sin theta by g. Maximum range, you can say that it will be 2u sin theta by g into how much? U cos theta. So this will be u square sin 2 theta by g. And in the same way, you have to keep in mind that maximum height is u square sin square theta by 2g. U square sin square theta by 2g. Up till now, this was very okay. Okay. Now, in this question, you can see here, we have said that the particle is projected with a speed u at an angle theta. with a speed u at an angle theta. Now, some of the understanding which we must keep in mind while dealing with the projectile motion is that the horizontal component of the velocity never changes. The horizontal component of the velocity vh never change. It remains same. Good morning, Immortal. It remains same to be u cos theta throughout. U cos theta throughout. Why? Because there is no force acting in the horizontal direction. There is no force acting in the horizontal direction. It is velocity in vertical direction that changes from zero, from maximum to zero, and again from zero to maximum. From maximum to zero, and again from zero to maximum. That is something which we should understand from the mechanics of this projectile motion. Everyone, is it clear? Are all these points making sense? These are very basic point, very small point, and these are very these points should be there with you all the time. Okay, if you want to solve the question of dynamics portion, or you can say that linear motion portion or projectile motion portion, these points should be on your tip. Clear? So now here what he is saying, that at the maximum height, you can assume it to be a part of small circle. Okay, it will be a part of circle at the highest point approximately. What is the radius of this circle? What will be the radius of this circle? Okay, no, these videos will be available to you. Now try to understand here. The only thing which we should keep in mind, which we should be having this idea, is that the velocity at the highest point or the peak point is v cos theta. Are we getting this? Okay, according to this question, it should be u cos theta. The angle at which it's projected is u. Okay, so this will be u cos theta. Now, if we are going to draw the free body diagram, then we will see that okay, only one force mg is acting vertically downward. Now, you should be having this concept of circular motion, that if a body is performing a circular motion, then it should be having an acceleration towards the center. Which can be caused by any force, whether it is gravitational force, whether it is normal action force, whether it is the resultant of both. Anything is possible. But here you should understand that at peak point, only one force is acting, which is gravitational force acting downward. Here only we will revise the concept of centripetal force and centrifugal force. Okay, now try to understand this one. Many of we get confused about the centripetal force and the centrifugal force. If I will, good morning Rajesh, if I will ask from you that which of the force, centripetal or centrifugal, which of the force is imaginary force? Please answer me, which of the force, centripetal or centrifugal, is an imaginary force? It do not exist in real. It is an imaginary force. Please inform me which of the force out of centripetal and centrifugal. Very good, Rajesh. It is centrifugal force, which is imaginary in nature, which is basically an inertial force. Very good, Shahrukh, which is basically an inertial force. Okay, so we can proceed the same circular motion using two concepts. One is centripetal method and another one is centrifugal method, or you can say one is Newton's law and another one is D'Alembert's principle. One is Newton's law and another one is D'Alembert's principle. Harsha, try to understand this. Centripetal force do exist in real whenever try to understand this, whenever a body is performing a circular motion. Whenever a body is performing a circular motion, then in that case you can find its mechanics that it is having some acceleration towards the center. It is having some acceleration, some real acceleration, some absolute acceleration with respect to ground towards the center. This is AC. Now, in order to have this AC, you must be having some force acting towards the center. Always. This is one approach of Newton's law. Newton's law that if a body is having acceleration in particular direction, then in that direction it should also be having some force. It should also be having some force. Another approach for the same problem is, say for example, a body is in acceleration. Then we will go for a centrifugal force. We will go for an inertial force, basically an inertial force which will bring the system into dynamic equilibrium. We do not want to study the dynamics part. We want to study the question or the problem as if the question belongs to static part. How we are doing this? We are doing this by using D'Alembert principle. We are making one more force acting on the body, with the help of which we will say that now the body is in equilibrium. Now the body is in equilibrium. This force which is acting inward is centripetal force. Which is acting inward is centripetal force. Now the force which is acting outward and which was applied by us, in order to bring the system into dynamic equilibrium. Why we are saying dynamic equilibrium? Because in actual the system is not in equilibrium. In actual the system is accelerating towards the center, but with the help of inertial force or with the help of D'Alembert principle, we are drawing some forces which will bring the body to appear like, which will make the body to appear like that body is in equilibrium. That is why we are saying it is available to our channel, Rajneesh, which says that okay, on applying the FC we will get the value of or we will get the system into dynamic equilibrium. Now here we are moving with simple centripetal force, that this force must be acting in such a way that it is providing you the acceleration, the centripetal acceleration. So mg must be equal to mv square by r, which is where v is obviously the tangential velocity, where v is actually the absolute velocity of the body. Here the velocity is u cos theta. So mv square by r, this is the simple relation which we can conclude if we are having the concept that okay, at the maximum height the velocity will be u cos theta only, and this force will be responsible for the centripetal acceleration. This force will be responsible for the centripetal acceleration, or this force is a centripetal force whose value will be equal to mv square by r. Very simple. Okay, from here you will be able to say that okay, r must be nothing but u square cos square theta by g. U square cos square theta by g. Are we getting this relation? Everyone, is it getting clear? These points you should keep in mind, that centripetal and centrifugal, What are the differences between centripetal and centrifugal force? What are the differences between centripetal and centrifugal force? How to approach the circular motion using Newton's law, and how to approach the circular motion using D'Alembert's principle. In classes we have taken these things in detail, but right now we are going for revision only, so we are taking like this. Okay, if anyone is having any doubt, then you should just go for the difference between the centripetal and centrifugal force, or you should go for the D'Alembert principle. Rest of the relation you must have the idea that how we are getting up to these relations. So R must be equal to U square cos square theta by G. You should understand this. You should understand this. We can go with centrifugal force concept also, that if a body is in circular motion, then a centrifugal force must be acting. It should be like mv square by r, mv square by r, where v is nothing but u cos theta. So this is mu cos theta square by r, which must be equal to mg, because after applying the centrifugal force, the body comes in equilibrium. No, Rajnish, centrifugal force is not the reaction of centripetal force. Try to understand this. Action and reaction do not act on the same body. Action and reaction do not act on the same body. If A will apply some force on B, then B will apply force on A. You are saying that centripetal force is also acting on block or on the mass, and centrifugal force is also applied on the mass. So action and reaction cannot take place on the same body. How come you are saying that mv square by r is greater than mg? Why we are saying that mv square by r is greater than mg? It should be equal to mg. If we are saying that this body is performing a circular motion, then in that case you will say that this mg is responsible for the acceleration, which is equal to v square by r. Or you can say that this is the centrifugal force which is acting on the body, which is obviously an imaginary force, but will bring the body or the system into the equilibrium, and using the equation of equilibrium, which we can apply over here also. But only thing we should keep in mind is that this is dynamic condition, this is a man-made condition. Harsha, how you are saying that mv square by r is greater than mg? How you are saying that mv square by r is greater than mg? Action and reaction cannot act on the same surface. Action and reaction cannot act on the same surface. If a block, u cos theta is the force we are giving. Okay, just a minute, let me clear your confusion first here. Try to understand this. Say for example, two blocks are pushing each other. Now if I am going to draw the free body diagram, of both the blocks, say this is A and this is B. Now other forces I am not showing over here, and this is normal reaction force. Now A has pushed B with the normal reaction force, then B has pushed A with the normal reaction force, same force, equal in magnitude and opposite in direction. Same force, equal in magnitude and opposite in direction. But if we are saying that this is action, then this is reaction, and if action is acting on B, then reaction is acting on A, which is visible to us. Action, if action is done on B, then reaction is done on A, or if action is done on A, then reaction is done on B. That is something which you should understand. Which you should understand. Now, here what is happening? Here what is happening? If simply I will say that okay, a body is there which is performing a circular motion, then using mathematics or using geometry, you will be able to say that okay, a body performing circular motion will always have some acceleration towards the center, will always have some acceleration towards the center. This acceleration will be equal to v square by r, where v is the tangential velocity. I'm getting this. This is velocity and this is our acceleration. Now, Newton says that if a body is having some acceleration in particular direction, then definitely the body must be applied by forces such that the net force must be acting towards that direction, and the relation between the force and the acceleration will be F is equal to ma. So using geometry, using mathematics, we concluded that if a body is performing a circular motion, even if the magnitude of the velocity is not changing, then also the acceleration is v square by r. So from here you can conclude that okay, some force must be acting towards the center, which is equal to mv square by r. This is simple thing. Okay, no issue, model. Some points can be missed. Overall you will be getting the complete idea. The concepts are told to you. Possibly these questions were not discussed with you. Okay, F is equal to mv square by r. This force must be acting towards the center. Now, in this case you can say that the force which is acting towards the center is mg. So mg must be responsible. One way of approaching the circular motion problem is saying that mg is equal to mv square by r. One way is this, and the another way, as you have said that okay, the body is accelerating towards the center. So instead of going for centripetal force concept, or you can say that Newtonian concept, you are going for centrifugal force concept. The centrifugal force says that a body accelerating in a particular direction can be applied by a force which is equal to mass into acceleration, and the force is acting opposite to the direction of acceleration. Once you will perform this activity, then the body will come into the dynamic equilibrium. So you will say that okay, we have applied here one force mv square by r. The body will come into dynamic equilibrium. Same thing we are doing here also. Once we can go directly by saying mg is equal to mv square by r. Second way, we can say that okay, one centrifugal force we are applying, which is equal to mv square by r, where v is u cos theta. Straight away we will be getting same answers using both concept. Okay, you should not confuse in between centripetal and centrifugal. Let's move to next question. A wheel of moment of inertia 0.1 kilogram meter square is rotating about a shaft at an angular speed of 160 revolution per minute. The second wheel is set into rotation at 300 revolution per minute and is coupled to the same shaft so that both the wheels finally rotate with the common angular speed of 200 revolution per minute. Find the moment of inertia of the second wheel. Okay, this question may appear to you that this question is bit tough, but this question is very easy. You just try to solve it. Okay, So this question belongs to conservation of angular momentum. Conservation of angular momentum. From question itself, you should understand that okay, here we are going to deal with the conservation of angular momentum. We have seen that, say in case if we are applied, if we are having some system where the linear momentum is conserved, then in that case we say that the momentum, linear momentum before particular event is equal to linear momentum after particular event. Okay, that particular event can be anything. It can be collision, it can be adding some mass, it can be removing some mass, it can be anything. But the thing is that if some conditions are fulfilled, then we can go for the conservation of linear momentum. Conservation of linear momentum. In the same way, here also you should understand that this question belongs to the conservation of angular momentum. Conservation of angular momentum. So we know that linear momentum is represented by mv. In the same way, angular momentum can be represented by I omega. We know that wherever there is mass for linear motion, it will be replaced by mass moment of inertia for angular motion or for rotational motion. Are we clear about this? We will get here the angular, the I, we will get here the I replacing m whenever we are dealing with the angular motion instead of linear motion. So we know that from conservation of linear momentum, m1 v1 is equal to m2 v2, or initial momentum is equal to final momentum. In the same way, here angular momentum is also conserved. Initial momentum will be equal to the final momentum. Initial momentum will be equal to the final momentum. Please answer me that what value you are getting. What value you are getting? So initial momentum is a wheel of moment of inertia 0.1, I is provided, is rotating at an angular speed of 160 revolution per minute. Okay, so I should ideally go for radian per second. I should ideally go for writing the omega in radian per second. But the good thing is that everywhere the omega is provided in the same unit. Everywhere the omega is provided in the same unit. So why to go for conversion? Why to go for conversion? The both side it will be having the same unit, it will cancel each other. Very good, Pranav. So from here you will say that 0.1 into 160 plus, initially say it is having some I into 300 must be equal to 200 into 0.1 plus I. Whether this relation is clear to you or not, whether this relation is clear to you or not, like in like in linear momentum conservation, we say that m1 v1 plus m2 v2 is equal to m1 plus m2 into v, whatever case it can be. Okay, in the same way, what is happening over here is a body is there which is having some angular velocity, and having some mass moment of inertia. Some I and omega is associated with the body, and inside one more body is there. Some I and omega is also associated with that. Now both are bring into the same shaft. Then they are asking that okay, now what will be the omega or what will be the I corresponding to that? Okay, now here the I becomes I1 plus I2. The I of the system becomes I1 plus I2, and the angular velocity of the system becomes omega. Angular velocity of the system becomes omega, which is provided over here, that is 200. So you should understand that I1 omega 1 plus I2 omega 2 must be equal to I1 plus I2 into omega. This simple understanding we are using over here. How we have concluded that okay, the angular momentum will be conserved using the language of the question only. Using the language of the question only. Okay, from here you will solve this will become equal to 16 plus 300I is equal to 20 plus 200I. From here you will get 100I is equal to 4. From here you will get I is equal to 0.04 kg meter square. Are we getting this? So this relation is something which we conclude. This relation is something which we conclude in the same way as we have concluded for the linear motion. Do not worry watching that instead of linear velocity they are having the angular velocity. Everything remains same. Just you have to keep the patience. Okay, try to understand that how the momentum concept comes. Okay, or you can say that how the linear momentum of the system remains constant. It comes from the impulse momentum equation. We will I will show here in terms of linear motion the same. In the same way you can use it for the angular motion also. Impulse momentum equation says impulse is equal to momentum change. And impulse is what? Impulse is force into time. Force into time is equal to change in momentum, is equal to 1 minute class. Impulse is equal to change in momentum. Change in momentum means final momentum minus initial momentum. Now try to understand this. Impulse momentum equation says that if a body is acted upon by a force for a small time t or dt, whatever it is. just a minute, Harsha. If a body is acted upon by a force in a particular direction for time t, then that will lead to the change in momentum of that body in that particular direction in which the force was applied. Once again, I'm telling you, impulse momentum equation says that if a force is applied on a body, if a net force is applied on a body in a particular direction for time t, then it will be responsible for the change in momentum of the body in that particular direction, in the direction which the force was applied. And the relation will be the change in momentum will be equal to force into time. How this relation comes? This relation comes with Newton's law of motion only. F is equal to ma only. A you can write as dv by dt. A you can write as dv by dt. So you will say here f dt is equal to m dv. F dt is equal to m dv. On integrate you will say that okay, ft is equal to mv minus mu. Now if f becomes equal to 0, then in that case you will say that okay, the initial momentum and the final momentum is same. Initial momentum of the system and the final momentum of the system is same. In this question also we can say, first of all, first thing first, that okay, what the data they have provided and what data they have asked, from there you should understand okay, they have provided something I and omega and they are asking some I. So from here you can conclude that okay, they must be talking about angular momentum. Now second thing is, from the whole question you will never feel like that body is under the action of some external torque. Here the F becomes 0. In this case the torque becomes 0, and when the torque becomes 0, the body will be having a condition where we can assume that okay, the initial angular momentum and the final angular momentum is same. Are you getting, Harsha? Are you getting? So from data or from the language of the question only, you can be able to understand that okay, what concept they are asking for, and if they haven't mentioned anything regarding torque, then you can understand that okay, here the angular momentum will remain conserved. Here the angular momentum will remain conserved. Are we getting this? You do not have to worry regarding these problems. You are here for the revision. It should not be like that okay, everything is already done by you. There can be some points which can be added right now also. These sessions can be like that also. Okay, so do not worry, do not get confused. Just stick. If you have gone through everything, if you are answering over here, well and good. If you are learning something new from here, then that is also very good. There is no issue. Should we move to the next question? Okay. The concepts are same. We are just following here that okay, whatever concepts you have learned, you can apply it like any way. Okay, it should not like the conventional questions whatever coming into the exam. I will put the same type of question over here, even if it is not required. Okay, there are so many questions can be possible using the concepts which they keep on asking. So we are just revising the concept over here. If you are watching some questions which appears new to you, then also that is okay. You do not have worry regarding that. Okay, that why this type of question is asking, or why this type of question we are discussing. We are discussing only the concept. In the same way here also, just see, a solid sphere is set into motion on a rough horizontal surface with a linear speed v in the forward direction and the angular speed v by r in the anti-clockwise direction. Find the linear speed of the wheel A when it stops rotating, B when the slipping finally ceases and the pure rolling starts. When the slipping finally ceases and the pure rolling starts. Try to understand this. Many of you can have this confusion. Okay, this condition that V by R is equal to omega, V by R is equal to omega, or you can say omega, V is equal to R omega has been fulfilled. V is equal to R omega has been fulfilled. So that means the system is already performing a pure rolling motion. System is already performing a pure rolling motion. But if you will observe carefully, you will find that omega is also asking point of contact to move in forward direction, and V is also asking point of contact to move in forward direction. So both are responsible, both are asking point of contact, say point of contact is O, point of contact to move in forward direction. So slip will be there. There will be velocity V because velocity of point of contact because of translation, and velocity of point of contact because of rotation also in the same direction. So V plus R omega, or you can say V plus R into V by R. From here you can say that 2V will be the velocity, 2V will be the initial velocity of point of contact. 2V will be the initial velocity of point of contact. Are we getting this point? Are we getting this point? Whether we are okay up till now? In case if they would have mentioned that okay, this is velocity and this is omega, the omega is clockwise, then in that case the body would have performed the pure rolling motion. But here the things are different. Try to understand this. If I'm saying that a body is performing a rolling motion, basically a general plane motion. Harsha, the velocity at point of contact is zero in pure rolling motion. In pure rolling motion, I'm coming to that only. Say for example, if I would have mentioned it like this, this is V and this is omega, and omega is equal to V by R. Omega is equal to V by R. These are the conditions which are fulfilled. These are the conditions which are fulfilled. Then in that case, what you would have said that okay, let's see the absolute velocity of point of contact. Let's see the absolute velocity of point of contact. From here you will say that okay, because of translation, the velocity of point of contact in the forward direction is v, and because of rotation, because of angular speed, the velocity of point of contact in the backward direction is r omega, and omega is equal to v by r, so r into v by r. Or you can say that because of translation, velocity of point of contact is v towards right, and because of rotation, velocity of point of contact towards left is v. So both will cancel each other, and the velocity, absolute velocity, becomes equal to zero. Absolute velocity becomes equal to zero. This is the case when v is towards right and angular velocity is clockwise, and angular velocity is clockwise. But here what we have mentioned, that v is towards right and angular velocity is anti-clockwise. So right now the point of contact is having 2v in the same direction. Are we clear regarding this? We should not lose the concept. We should not lose the concept. Pure rolling surely means that point of contact is having zero velocity. But here the pure rolling condition is not there. Here only the rolling condition is there. And even if I am saying that here the rolling with slipping is occurring. Rolling with slipping is occurring. Okay, now that is okay. That is very, very good. That is something which we understood. That right now the point of contact is not having this zero velocity condition, or you can say that the system is in pure rolling condition. Right now the system is not in pure rolling condition. Okay, now what will happen, since here they haven't mentioned anything regarding the surfaces, and of course if the surface will be smooth, then the system will keep on moving, having the same velocity, of point of contact 2v towards right. But in question they have mentioned that somehow after a while, somehow the rotation will stop, and somehow after a while the slipping finally ceases, or pure rolling starts. In order to do that, in order to get into that situation, you should understand that friction must be there. Friction must be there. They haven't mentioned anything about friction, but the condition which they have mentioned in the question, from that we can say surely that okay, friction is acting on the body. Friction is acting on the body. Are we getting this? Point of contact is slipping with respect to surface with a velocity 2v right now, and since it is slipping, so friction will start acting towards backward direction. So friction will start acting towards backward direction. Friction will start acting towards backward direction. Up till now, is it okay? Up till now, is it okay? This is the situation of the question right now. In the beginning, this is the situation of the question. There are many times they have asked from these type of questions. Okay, so these questions are not new. We can go for simple questions as well, but we are here to revise using the maximum possible level of question. Do not worry after watching these questions. You're just revising over here. You're just making things more clear. Everyone, is it okay? So here right now the condition is the friction is acting at the point of contact. Why? Because the point of contact is having the net velocity of 2v with respect to the surface. Since point of contact is slipping, therefore there must be friction acting in the opposite direction. Clear? You are here to gain something. You are not here to get demotivated. Okay, so just study it like that only. These are few concepts which they have already asked in one way or other. Okay, some of you may have gone through all the concepts, some of you may find some concepts, some new concepts over here. But the thing is, you will be able to get the idea of how to use those concepts, or you can say that how those concepts can be asked. Clear? So from here, the friction is acting in backward direction. Now, if I will ask from you that okay, after a while the situation will be like this. After a while, the situation will be like this. Say the body will be having some velocity v dash. Body will be having some velocity v dash, and omega becomes equal to 0. This is our case A. This is our case A, at which the v dash is asked, and we are having another case B, where V double dash will be there, V double dash will be there, and corresponding to that omega double dash will be there. Why? Because is still after reaching to condition A, the point of contact will be having some velocity V dash towards right, and still the friction will be acting towards left. So this from starting to A, and from A to B, the friction will keep on acting towards left. The friction will keep on acting towards left. Are we getting this? Are we getting this? Now, the thing is that friction is acting on the body. Friction is acting on the body. So we cannot go for conservation of angular moment, sorry, conservation of linear momentum. Conservation of linear momentum. Are we getting this point? We cannot go for conservation of linear momentum. Why? Because the friction is acting, a force, an external force is acting throughout these cases. Throughout the time, the friction force is acting. A body is applied by some force will feel the change in momentum. So we cannot go for conservation of linear momentum, but we can go for conservation of angular momentum. Conservation of angular momentum about any point on the surface of the body, about any point on the surface of the flow, try to understand this. When you will draw the free body diagram of this, wheel, you will say that here mg is acting, here N is acting, and one friction force is acting towards left. Now, if I will ask that about any point on the surface of the earth, whether there will be any torque, then in that case you will say no, the torque will not be there because of these three forces. Why? Because Ng and N are equal in magnitude, and they both will have the same momentum. So you can say that mg and n will not be responsible for any torque. In the same way, since friction itself is passing from point A, so you can say that friction is also causing no moment about point A. So the this body which we are dealing with here, the body with which we are dealing with will have no net torque about any point on the surface of the earth. We are just considering any point, say point A is there. We are considering any point, say point A is there on the earth surface. Is it clear to know? So from A, if the observer is standing at point A, if we are making the observation from point A, then the body will be having the constant angular momentum. Are we clear up till now? Class, are we clear up till now? Okay, now we understand that okay, one approach can be possible, that we can go for the conservation of angular momentum about point A. Now let me tell you one more thing before reading from here. Whenever I am saying that what is the angular momentum of the body, if the body is in pure rotation about point, C, say about point C, about point center, what is the angular momentum of the body? Then the angular momentum of the body will be IC into omega, IC into omega. Okay. Say for example, if I will say that okay, a body is there which is performing a pure translation motion, then in that case, what is the linear momentum? The linear momentum is mv. But if I will ask that what is the angular momentum about point A, then you will say that it is equal to mvr or mv. Say this is r. So this is r. Then you will say that the angular momentum about point A will be mvr. So angular momentum is find out with the help of these two concepts, that okay, if there is pure rotation, then the angular momentum will be ic omega. If there is pure translation, then also we can determine the value of angular momentum. The only thing is the angular momentum will keep on changing the observer. Here the angular momentum do not change on changing the observer, but when we change the point of observation, then in that case the angular momentum will change. Then in that case the angular momentum will change in case of pure rolling, in case of pure translation motion, Okay, so here also what we are doing is, because this motion is a general plane motion, and general plane motion can be assumed to be a resultant of pure rotation and pure translation, so in first case the body is assumed to be in pure rotation about its center. It can be assumed to be in pure rotation about its center, and in second case you can assume that the body is moving with a velocity v. The combination of these two is giving us a general plane motion. Now we are dealing both of them separately because we are calculating the angular momentum about point A. Now I have told you that when the body is in pure rotation, then independent of the observer, the angular momentum will be I into omega, IC into omega. Here the IC will be, because they have provided it to be a solid sphere, so IC will be 2 by 5 mr square into omega, and v, because of v, what momentum you will find about point A, it can be assumed that okay, whole mass is located at the center and it is moving with a velocity v. So you can say that the angular momentum of this pure translation motion about point A will be mvr. About this point A will be mvr. Now, one thing you should understand from here, one observation you should make from here is that first of all, let's replace omega is equal to v by r. So this will be 2 by 5 mvr, and this is mvr. Now, if I will say that what is the net angular momentum? What is the net angular momentum of this system? Please answer me, what is the net angular momentum of this system? So now here you should observe that angular momentum is basically a vector quantity, so the direction is also associated with it. In one case it is anti-clockwise. However, we determine the direction using right hand thumb rule, but you can directly say that because of rotation it is anti-clockwise, and because of translation you can find that about point A it is clockwise moment. So say for example, if I am taking clockwise to be positive, then this is plus mvr and this is minus 2 by 5 mvr. So the net angular momentum about point A in the beginning was mvr minus 2 by 5 mvr. From here you can say that it will be 3 by 5 mvr. So this is our initial case, the angular momentum in the initial condition. Angular momentum in the initial condition. Are we clear up till now? How we got mvr minus 2 by 5 mvr? Are we getting this? Everyone, is it okay? Is it clear? We are just observing that what are the possibilities. What are the possibilities? So the angular momentum initially will be 3 by 5 mvr. 3 by 5 mvr. Now for case A, you can say, for case A, what will be the angular momentum after reaching case A? What will be the angular momentum about point A? The rotation has ceased. Rotation has ceased for now. Then you will say that okay, only momentum will be because of the linear velocity. Only momentum will be because of the linear velocity, and you can directly say no. Initially if we have taken the point A to be the point about which we are going to say that the momentum, net momentum, will be conserved, so here also the point A will remain same. Here also the point A will remain same. You cannot go to any point, any other point on the in the basically in the reference frame. Why? Because if you will change it, there are two procedures basically. One is observing it in a way that the body is in pure translation plus pure rotation, and the second observation is observing it in a way that okay, from point A, how the body will appear like, and in that case you will go for the component of the velocity. That velocity is one component is responsible for the angular momentum. So two methods are there. Because we have moved to the simpler method, so we are saying that it is better not to change the observer. It is better not to change the observer, because if you will change the observer, then in the second method you will feel the difficulty. So now you cannot change the observer. Okay. From here still the radius is r only. V dash is the velocity. We have to determine the v dash only. So from here you will say that now the angular momentum about point A is mv dash r. mv dash r. From conservation of angular momentum, you can say, since the angular momentum is conserved about point A, so mv dash r must be equal to how much? 3 by 5 mvr. 3 by 5 mvr. From here you will say that okay, v dash must be equal to 3 by 5 v. V dash must be equal to 3 by 5 v. V dash must be equal to 3 by 5 v. Are we clear regarding this? Now case B. Case B, please tell me, please you people, please tell me what will be the angular momentum. What will be the angular momentum in terms of V dash? What will be the angular momentum in terms of V dash? Because they have V double dash basically, because they have told that okay, now from here at point at in the situation of case B, the pure rolling begins. So you can say that V double dash is equal to R omega double dash. V double dash is equal to R omega double dash. Please tell me that what is the angular momentum about point A in case B, when we reach to point B, when we reach to point B in terms of time. So here it will be mv double dash into R plus I omega, which is 2 by 5 m r square into omega double dash square, and using the relation that v double dash is equal to r omega, we will say that m v double dash r is equal to 2 by 5 m omega double dash. We can write v double dash V double dash by R. What will be the value right now? What will be the value? Please tell. So here you will get mv double dash R plus 2 by 5 mv double dash R. Here, because rotation is clockwise and V is also directing in such a way that both of them will be responsible for clockwise angular momentum about point A. For clockwise angular momentum about point A. So you can say that the value will be 7 by 5 mv double dash R. 7 by 5 mv double dash R. This is your new angular momentum when the B is state B is reached. State B is reached. Since we know that about point A, the momentum is not changing. Angular momentum is basically not changing. Why? Because no net torque is there about point A. So we can say that 3 by 5 mvr must be equal to 7 by 5 mv double dash R. mv double dash R. From here you can find that okay, v double dash is equal to 3 by 7 v. 3 by 7 v. Are we clear up till this point? Everyone just inform me. Are we clear up till this point? So straight away, just watching that okay, the body is in rolling motion. It doesn't mean that the body is in pure rolling motion. The body is in rolling motion doesn't mean the body is in pure rolling motion. First thing we have revised that there is possibility that okay, initially the body is just in rolling motion and after a while the body can come into the pure rolling motion. How the friction force is acting, how it is causing the linear momentum to change, but it is not causing the angular momentum to change about point A. We have seen everything. These the level of this question can be assumed to be higher than the level of the questions which we are going to face in GATE. But the thing is, once or twice they have asked regarding these concepts. That is why we have kept this into our into our sessions. Many of you must have seen one question which came that okay, a mud is coming to the system and is hitting the sphere. After that the sphere starts rotating with pure rolling motion. The same concept we are using here also. However, the collision has been removed from your syllabus. But the rest of the concept can be asked right now also. Are we clear about this? How to calculate the angular momentum in pure rotation? How to calculate the angular momentum even when the body is performing pure translation? How to calculate the angular momentum in general plane motion? How to calculate the torque? How to say that okay, net torque about a particular point is zero? How to say that if a net torque is zero, then you can say using impulse momentum equation for rotation that or for angular motion that since net torque is zero, so you can say that angular momentum before or initial angular momentum is equal to the final angular momentum. Are we clear up to all these points which we have discussed now? Please inform. Let's move to the next question. This question is simple and straight away taken from the GATE previous year only. The objective was make you to understand that okay, rolling friction is having some concept. Rolling friction is having some concept. From rolling friction, they cannot ask as far as numericals are concerned, they cannot ask varieties of question. Okay, this is a one type of question that can be asked. In one way or another, they would have provided you the weight, they would have provided you the diameter, they would have provided you the rolling resistance, everything. That we will discuss here only. That is why I have kept this rolling friction question straight away from the previous year only. The second thing is that what to understand for you is, in this question they haven't mentioned anywhere the body is accelerating. In this question they haven't mentioned anywhere the body is accelerating. The body is just rolling. The body is just rolling. I will take you for some revision that whenever you're talking about rolling motion, then in that case we do not consider the body to accelerate. Okay, in the simplest way the question can be asked is like this: what is the amount of force, which is required for a body to roll, which is required by a body to roll? The whole system will appear like this. Just see here, the whole system will appear like this. Rolling friction in terms of force, can be defined as the amount of force which is required in order to make the body rolling. Try to understand this. Whoever has seen the sessions which we have taken, which we have especially dedicated to the new topics, they have seen the everything in detail, that what is the reason of rolling friction. Rolling friction is completely different from the friction concept. Even the coefficient of rolling friction, you can see over here, is having some dimension. But here we can go only for the revision. Using the question only. The thing is that what is causing a body to stop even if the body is moving with a pure rolling motion with a constant velocity? We have seen that in ideal condition, if the body is perfectly rigid, then in that case you can assume that the body will keep on rolling with constant linear velocity, even when there is some friction between the surfaces. Why? Because the point of contact will not have any linear velocity, and that's why it will always appear to the surface of the earth that the body is in stationary condition only. Therefore the friction will not be acted by earth on the surface of the body, and so the body can move, or you can say the body can perform the pure rolling motion throughout its life. But in actual, very good, but in actual the deformation do occurs. First thing, the deformation do occurs. Second thing, some in one way or another some energy get lost. Just see here, whenever you will say that in deformation, while causing the deformation, what are the forces which were acting, and while recovering back from that deformation, what are the forces which are acting? So this is something which you can say that it is deformation versus force curve. Okay, so here you can find that this was initial condition 1 2 3, from 3 to 4, and 4 to 1. From 1 to 2 to 3, what is happening? Actually, the portion of the wheel is getting deformed, and then getting recovered back, Okay, but here you will find that the amount of energy which was lost during the deformation is not recovered completely. This loss is said to be hysteresis loss. This loss is said to be hysteresis loss. So if they are going to ask the question, in terms of theoretical point of view, then they can ask what are the reasons for the rolling friction. Then you can say hysteresis loss, you can say deformation. Okay. The overall idea is the distribution of pressure will appear like this. The distribution of pressure will appear like this. And here you can replace this whole system. By a force which is acting like this, mg is acting here. Okay, now if I will say that r is having two components, one horizontal and one vertical, then you will say that okay, this vertical will be responsible for balancing gravitational force and this horizontal will be responsible for balancing the external force, and the moment which is causing because of mg and r is equal to the moment which is causing because of f and fr. Here the fr is called as the rolling friction. Try to understand this. This concept is, one minute just. This concept is basically modeled. That if a system, if a body needs to roll without stopping at a constant velocity, then in that case we need to give some force, because this is the real world scenario, that if we want a body to perform pure rolling also, then in that case we need to provide some f. Okay, so we have modeled everything like that, fr is equal to rolling friction. Fr is said to be rolling friction. The force which is equal to the amount of force which is required by a body in order to perform a pure rolling motion or a rolling motion at a constant velocity or at a constant speed with time. Okay, with time the velocity is not changing. If we don't want the velocity of the body to change, or the linear velocity of the body to change, or the linear velocity of the center of the mass to be changed, then we say that there must be some force which is acting on the body throughout the motion, and that force is equal to the amount of rolling friction. Okay, how to determine the value of this fr? We say that the point at which this n gets shifted, or the component of r is acting, we can say that this is acting at a position small r, This small r is nothing but coefficient of rolling resistance. Okay, now we should understand this body is moving with a constant linear velocity. The center of mass is having constant linear velocity. The body is basically not accelerating, it is performing a rolling motion. So net force in any direction must be zero, and similarly net torque must also be zero. From here you can conclude that okay, F into R must be equal to how much? F into R must be equal to N into small r. n into small r. Okay, and small r is nothing but the coefficient of rolling resistance. In case if they haven't mentioned the unit to be mm along with coefficient of rolling resistance, then how to deal with that question, we will discuss that also. But right now, because they have mentioned that okay, the coefficient of rolling resistance is something like this, then how to deal with that question? Just see here, f is nothing but fr only. N is nothing but, you can say, summation of fy will provide you that n must be equal to mg. N must be equal to mg. And from question you can say that mg is nothing but the weight, which is equal to 500 newton. The resistance, sorry, the dia of the steel wheel is provided as to be 600 mm. So you can say that the radius will be 300 mm. Radius will be 300 mm. As far as f is concerned, f into 0.3 must be equal to 500 into 300. 500 into 300. Is it clear? So from here you can say that f must be equal to 500. Just a minute. Sorry. F into 300 must be equal to 500 into 0.3. 500 into 0. Here it is the coefficient of rolling resistance, and here is the radius of v. Here is the radius of v. Okay, from here you will find that okay, this is 5 into 0.3 by 3, which is equal to 0.5 newton, which is equal to 0.5 newton. So force which is required by a body, to perform pure rolling without being stopped is 0.5 newton. 0.5 newton. Are we clear up to this point? Try to understand this. Whenever we are talking about non-accelerating system, the wheel is actually not accelerating. Okay, then up till that point only we can say that okay, we can discuss the rolling friction. But once the system get accelerated, once the system start accelerating, then in that case the rolling friction do exist there also, but the rolling friction uh, do not appear in a way we can say that the rolling friction, the amount of rolling friction cannot be considered with respect to the other forces, So these are the conditions which you must understand, that how we are reaching up to this point. We can directly memorize this formula also, that f into r is equal to n into small r, where r is the coefficient of rolling resistance, The overall idea is that in ideal situation or in rigid body condition, we say that the body do not need any force in order to perform pure rolling motion with a constant linear velocity of the center of mass. But in actual case, it is not the condition. In actual case, we do need some force in order to make the body to roll. What is that amount of force? That amount of force can be calculated like this. Okay, what is the reason of the requirement of that force? The reason is that hysteresis loss do occurs within the component that is responsible for the loss of energy. Okay, so overall, one model is framed which will help you to understand that the system is not accelerating; it is moving with a constant linear velocity. But for that also, some force is required. Some force F is required. How to calculate that F? With the help of equations of equilibrium. Clear? Is it clear, everyone? Is it clear? All these points are clear to you? All these points are clear to you or not? If someone is having any confusion, in rolling friction or the new topics which are added, you can visit our channel also. There we have covered the rolling friction portion. Okay, I think Higam sir has covered that portion, so you can find that portion also uh, in much detail. But if it is required for you, or if you consider that okay, this is important, Right now, these formulas is more than sufficient for you to answer every question possible over there. Okay. Now, the next thing, one more thing which I want to add over here is, say for example, if they have mentioned that, okay, the mu r is provided to be 0.05, and they haven't mentioned anything in unit. They haven't mentioned anything in unit. That is also a possibility, because sometime what happens, making the conditions analogous to static friction or dynamic friction, sometimes we represent the rolling friction, the coefficient of rolling friction in unitless quantity. In that case, you have to do simple thing. You just have to calculate the FR. You just have to calculate the FR by saying that FR is equal to mu R into N. Mu R into N. Now, in that case, you do not need anything like radius of the wheel. Anything like radius of the wheel. Straight away, you can go for this formula. Are we clear about this? This is there is very limited possibility of giving you data in such a way, but still, if in case they have provided, because these are some things which are available in market, that is why we can discuss that also over here. Are you getting this? In case if they haven't mentioned anything regarding unit, then you can straight away go for the same formulas as you are going for static or dynamic friction. Static or dynamic friction. Static or kinetic friction. Okay, clear? Should we move to next question? Okay. So one more topic which have been added this year was Lagrangian method or Lagrangian mechanics. Try to understand this. The derivation of the Lagrangian equation needs higher mathematics, which is not even in your course. So we will deal only with the equation of the Lagrangian. Okay, we are not going to deal how that equation comes, because that needs some higher mathematics, which is not even the syllabus of your engineering mathematics. Okay, which is not even the syllabus of your engineering mathematics. So something which you should keep in mind, because you can consider that this year they are going to ask some question which will straightforward from the formula, you can say. So you should understand that what is the Lagrangian function implies. So Lagrangian function is kinetic energy minus potential energy. Lagrangian function is kinetic energy minus potential energy. First thing first, okay, this is something which you should keep in mind, and the second thing is writing the Lagrangian equation, that is time derivative of d by dt of del L by del x dot minus minus del L by del x minus del L by del x is equal to 0. These two relations you should keep in mind if you are going to solve the question of Lagrangian equation. These are not very tough things. Okay, you just have to see in which way they are going to ask the question. These two relations you should keep in mind. Here del x dot means velocity, and x means obviously displacement. Now you should understand that Lagrangian mechanics or Lagrangian equation deals in general coordinates. you can straight away write here that okay, this is x. This is x. Corresponding to that, you can mention the displacement, and corresponding to that, you can mention the velocity as well. You can mention the velocity as well. So from here you can say, that if we are considering it to be from the neutral position, say we are considering x from neutral position. Okay, so the displacement is x and the velocity is x dot. Velocity is x dot of the system. Velocity is x dot of the system. Now if I will ask from you that okay, what we have to calculate the natural frequency. We can calculate the natural frequency by reaching up to an equation which will appear like x double dot plus kx, yeah, or x double dot plus kx by m is equal to 0, something like that. But how to reach up to that equation using Lagrangian, that we are dealing over here. Okay, good morning, Hariom. So from here you can say that L is equal to kinetic energy minus potential energy. What is the kinetic energy and what is the potential energy of the system right now? The kinetic energy is associated with the mass and the potential energy is associated with the spring. Kinetic energy is associated with the mass and potential energy is associated with the spring. You can say here that L is equal to half m v square, or you can say half m x dot square minus half kx square minus half kx square. So you got the value of L. You got the value of L from here. They can provide you directly that okay, this is your L, and determine the equation of motion. Determine the equation of motion. Try to understand this. The objective of Lagrangian equation is simply dealing those questions which are very tough. Even the smaller question, even the simpler question which can be dealt with the help of Newton's laws of motion or Newton's equations directly, we can deal those questions also. But that will be meaningless to us. Right now, because the Lagrangian mechanics is introduced into our syllabus, and we can also consider that they are not going to ask very deep questions, okay, very tough questions from here. They just want you to understand that there is some mechanism which do exist in nature which can help you to solve tougher questions also, okay. That's why they have mentioned the Lagrangian equation in Lagrangian mechanics into your syllabus. Now what is the value of L? L is equal to half mx dot square minus half kx square. Corresponding to every situation, this L can change. Are we clear up to this? Corresponding to every situation, this L can change. There is no issue regarding that. But right now, for this question, the L is equal to half mx dot square minus half kx square. Now we have to write the equation, Lagrangian equation. So for that, first we need to calculate partial derivative of Lagrangian function with respect to velocity. That will be half m 2x dot x double dot. Sorry, half m 2x dot minus 0, half m 2x dot minus 0. This will be mx, mx dot. Okay, now we also have to determine the value of del x by del x partial derivative. This will be minus half k into 2x, half k into 2x. This will be minus kx. Now putting the value of mx dot and minus kx into our Lagrangian equation 2, we will say that time derivative of partial derivative means mx dot minus of kx is equal to 0. From here you can say that okay, m is constant, m is assumed to be constant, and the time derivative of x dot will provide you acceleration. This will become mx double dot plus kx is equal to 0. From here you can say that okay, it appears to be something like x double dot plus omega n square x is equal to 0. From on comparison you can say that omega n is something under root k by m. Omega n is something under root k by m. So you are reaching to the final results which can be reached with the help of D'Alembert principle or with the help of Newton's laws, Newton's second law of motion also. But using Lagrangian equation or Lagrangian mechanics also, we are reaching to the same results. The only thing is we should keep in mind these two relations. We should keep in mind these two relations. Are we clear? Are we clear? The topic is very new to you. The topic is very vast, but you should understand that they are not going to frame any such question. They will keep the limitation of their question in these few conditions only. That you should be having this idea of what the Lagrangian equation is, what the Lagrangian function is. Lagrangian function is kinetic energy minus potential energy. It can be anything depending upon the system. It can be anything depending upon the system. And what is Lagrangian equation? It is time derivative of partial derivative of Lagrangian function with respect to velocity minus partial derivative of Lagrangian function with respect to displacement. Everyone, is it clear? So we have discussed the concepts of Lagrangian motion. We have discussed the concepts of rolling motion. We have discussed the concept of linear motion. For all cases, Vijay, for all cases it can be applied. For all cases, for any question it can be applied. Okay, so most of the part we have dealt rotational motion, we have dealt translation motion, we have dealt circular motion. Everything was discussed in detail in this session. One more question we can see over here. Just see here, and then we will end the session. A uniform rod of mass m and length L, length A lies on a horizontal plane. A particle, first thing first, it is placed on a horizontal plane surface. This rod is placed on horizontal plane surface. So do not get confused that where the gravitational force is acting. Gravitational force is acting perpendicular to the plane and inward, and corresponding to that, a normal action force is acting perpendicular to the plane outward, which is balancing it. Okay, so do not get confused regarding that. Okay, Shahrukh, which step you are asking? This is mathematics. This is mathematics, and something which you have read in vibration, that if some equation like x double dot plus omega n square x is equal to 0 will appear. Omega n square x is equal to 0 will appear, then this is the case of vibrational model where the angular frequency is equal to omega n. If this equation comes into existence, then that means the system is performing a simple harmonic motion. Are you getting this? So this is something which we have covered in theory of machine. Okay, here also we are reaching like that only. Mx double dot plus kx is equal to 0. This says that x double dot plus k by mx is equal to 0, or you can say that okay, omega is equal to under root k by m. That is the angular frequency of the system must be equal to under root k by m. Okay. So this is placed on a horizontal surface. This is placed on horizontal smooth surface. Horizontal smooth surface. The question says that a uniform rod of mass m and length L, length A, the total length is provided. Total length is provided to be A. The particle of mass m moving at a speed v perpendicular to the length of the rod. Perpendicular to the length of the rod, a particle is moving with velocity v. Moving with velocity v. Strikes it at a distance a by 4. Strikes it at a distance a by 4. This is your a by 4 from center and stops after the collision. Stops after the collision. Find the velocity of the center of rod. Find the velocity of the center of rod. Second, the angular velocity of rod about its center just after the collision. About its center just after the collision. So you have to do nothing. You just have to keep in mind that this whole system is, this whole rod is kept on a smooth surface, smooth horizontal surface. So the smooth term is very important to us. And if the system is smooth, if there is no friction loss, then we can go for conservation of linear momentum. Conservation of linear momentum directly. Straight away we can go for conservation of linear momentum. The mass of this ball is m and the mass of this rod is capital M. You can say that m into v must be equal to capital M into v dash. From here you can say that v dash must be equal to mv upon m. mv upon m. Okay, so this relation should hold good. This relation should hold good anyway. Why? Because you should understand that here, because there is no friction loss, so of the system will remain conserved. Will remain conserved. In the same way, here the angular momentum will also remain. The angular momentum will also remain conserved. Just a second. So V dash can be calculated directly by saying M into capital V upon M, capital M, MV upon M. No, Pranav. After collision, the mass will not be m plus m. Just see here. You should watch the question carefully. A particle of mass m moving at a speed v perpendicular to the length of the rod strikes it at a distance a by 4 from the center and stops. Okay. If in case they have said instead of stop, they have said it sticks. Then in that case, you would have said that okay, the mass now becomes m plus m. Now the mass becomes m plus m. But here they have said that the mass get stopped, so we haven't considered the small mass into the final linear momentum. Pranav, are we clear? In the same way, the angular velocity they want you to know what is the angular velocity. You can go for the conservation of angular momentum about the center. You can go for the conservation of angular momentum about the center. So the conservation of angular momentum will say that okay, this velocity of the ball, this mass having some velocity will have the angular momentum to be mvr. Angular momentum before collision will be mvr. R is something a by 4. R is something a by 4. What we are doing, we are writing the angular momentum about the center. Angular momentum about the center is equal to I into omega. Is equal to I into omega. The final angular momentum. Final angular momentum. What is I? I is the I about the center of the rod. I about the center of the rod. What is the I about center of rod? ml square by 12. ml square by 12. So this is m. L is something a. ma square by 12 into omega must be equal to m v a by 4. mva by 4. From here you can determine the value of omega to be, this becomes 3. So this becomes 3 mv upon capital M A. 3 mv upon capital M A. This will be your omega. This will be your omega. This will be your omega. Are we clear? These are few points which we should keep in mind. Which we should keep in mind. We have dealt everything in detail, and I have kept those topics, especially those topics which are not generally told in classes. Okay. So do not get worried after watching this. These are also important topics, and they have asked the questions regarding these topics. Everyone, is it clear? Whether there is any doubt, regarding engineering mechanics, we can discuss it over here now. Whether there is any doubt regarding engineering mechanics, you can ask here. The concepts which we have gone through are very important. Please go through it once. Even if you need some quick revision, then we are also having a session. We had a session last year also, which was also helpful. Some of the topics like collisions are also kept in there, but you can skip those portions. These concepts which we have discussed in this session are bit different from those. Okay, so if you want to cover some topics, some more topics also, then you can watch our previous sessions also. This is not only for engineering mechanics, this is for every subject. This is for every subject. Right now, if anyone is having any issue, we can discuss it over here, or else we will stop. Regarding engineering mechanics, if you want to ask anything, you can ask right now. Okay, just see it once. We have gone through the concept of circular motion. We have gone through the concept of circular motion and projectile motion in the first case. Before that, we have dealt with the linear motion concept, that if a system is performing a linear motion, then these are the relations: v is equal to ds by dt, a is equal to dv by dt, a is equal to vd by ds, a is equal to del s by del t square. These are the relations which holds good and which comes only from the definition of the velocity and acceleration itself. Okay, time rate of change of displacement is called velocity, time rate of change of velocity is called acceleration, everything like that. Okay, say if the acceleration is constant, then you can use these equations also. These equations are v is equal to u plus at, s is equal to ut plus half at square, something like that. Oh, now these equations cannot be used if the acceleration is not constant. What to do then? Then you have to go to the general or the basic formulas that will help you to determine whatever you need. Okay, so after revising this, we have came through that okay, for projectile motion, you should remember some points. These formulas are applicable only when the body is moving from ground to ground. Okay, in case if the body do not move from ground to ground, then you just have to keep a simple thing in your mind that that the vertical motion and the horizontal motion are separated, and in vertical motion we are having this and this velocity, this and this force. Which force is there acting throughout the motion is gravitational force. What about the horizontal motion? Horizontal motion, there is no force acting on it, and that is why we say that throughout the motion the velocity do not change. Throughout the motion the velocity do not change. So here you say that the maximum height is u square sin square theta by 2g. That is something which you should remember. That is something which you should remember. Total height, total time of the flight is 2u sin theta by g. That is something you should remember. And the range is u square sin theta by g. That is something you should remember. The angle at which the range is maximum is theta is equal to 45 degree. Okay, after watching up till here, we have seen that okay, now in this question, it is assumed that at the top of its path, it is assumed to be performing a circular motion. What is the radius of this circular arc? What is the radius of this circular arc? They have asked. Okay, now here the velocity we know by the concept that when we separate the motion into two parts, the horizontal motion and the vertical motion, we will say that the horizontal velocity do not change throughout the motion. So the velocity will be u cos theta, and what is the radius? What is the radius of this circular path? They have asked. Now here you can apply either Newton's law, either Newton's laws of motion, Newton's second law, or you can apply, or you can go for D'Alembert principle. Anything you want. If you're applying Newton's law, then you are dealing with centripetal force. If you're applying D'Alembert principle or inertial force concept, then you are dealing with centrifugal force also. Okay, in Newton's law, Newton's second law, what we see that the body is accelerating in a particular direction, then in that case there must be some force which is acting in that direction. Here the force acting is gravitational force. So you will directly straight away say that okay, mg is equal to mv square by r. Mg is equal to mv square by r. Just a second, class. Mg is equal to mv square by r. V is something u cos theta by r. From here you can say that what will be the value of r? It will be u square cos square theta by g. U square cos square theta by g. Same thing you can find by centrifugal force concept also. You can bring this system into dynamic equilibrium by applying the inertial force, which will act in the direction opposite the direction of the acceleration of the system. The acceleration is towards center, so you can say that the system is acted upon by an imaginary force mv square by r, and here it is mg. Okay, so from here you will find that what is the relation or what is the value of r. So these are the topics which we have covered in our first question. In next question we have seen that how to apply the conservation of linear momentum and how to apply the conservation of angular momentum. If some net torque is zero, then the angular momentum will remain conserved. If some net force is zero on the system throughout the time, then in that case we will say that okay, the linear momentum will remain conserved. How we reach to these points? We reach to these points using impulse momentum equation. How we reach to impulse momentum equation? We reach to impulse momentum equation using Newton's second law. Impulse momentum equation says that if a system is acted upon by a force in a particular direction, then in that direction we can observe the change in momentum of the system. And if there is no net force acting on a body, then in that case we will say that the final momentum and the initial momentum will remain same. Clear? Is it clear? The second concept which we have gone through, in second question, is it clear? Vijay, in next question we have seen, that okay, this body is performing rolling motion. Please mind it, it is performing rolling motion, it is not performing pure rolling motion. If as if now, okay, initially it is not performing pure rolling motion, it is left with a condition that the body is having some linear velocity towards right and some angular velocity in counterclockwise direction, because of which the point of contact is having some relative velocity with respect to surface. And from the question you can assume that friction must be acting, because of which only ultimately the body will come into pure rolling motion. Now we have seen that because the friction is acting, so the linear momentum is not remain conserved, but the angular momentum about any point on the surface of the earth will remain conserved. Why? Because we have seen from the free body diagram, that mg and n will pass to the same point, and the moment arm corresponding to both the forces will remain same. What about friction? Friction itself is passing from point A. Therefore, we can conclude that no net momentum, no net torque about point A exists on the body. So we can say that if we can determine the value of angular momentum of the system about point A, then that body, that angular momentum will remain conserved. It will not change with the application of friction. So we have seen that how to calculate the angular momentum. We have seen that this is the way to calculate the angular momentum in case the body is in pure rotation, or in case if the body is in pure translation. Here, because the performance is a general plane, the motion is a general plane motion, therefore we have to include both separately and we have to add it together. We have seen because one is performing anti-clockwise and one is performing clockwise, or you can say one is having anti-clockwise angular momentum and one is having clockwise angular momentum. So we have kept negative sign with anti-clockwise and we have calculated the initial angular momentum to be 3/5 mv/. Next, we have seen that after in case A, it was said that what will be the velocity v dash, when the system is performing the motion such that the omega is zero, then straight away we calculated that mv dash r must be equal to 3/5 mvr. How? Mv dash r, it is the angular momentum of the body at this instant about point A. In the same way we have calculated for case B also. Okay, now in next question we have seen the concept of rolling friction. The rolling friction concept says that in ideal condition, however, in ideal condition we do not need any force, but in real world scenario we need some force in order to move the body, or in order to make the body uh, pure roll at a constant velocity. However, in ideal situation, in a rigid body condition, we do not need any such force. Now, in real world situation, because we need this much of force, how to calculate that force? We have given a model, and with the help of this model, we have said that okay, the net omega remains constant, the net velocity remains constant. Therefore, how to calculate the value of Fr? By the help of summation F is equal to 0, summation Fy is equal to 0, and net moment about any point is equal to 0. We have calculated the net moment about, say this is the point C. Say this is point C. So when we calculate the net moment about point C, or we can calculate it from anywhere, we will get that Fr into R must be equal to N into R, where small r is coefficient of rolling resistance. The R, or you can say that coefficient of rolling resistance is the distance by which the normal reaction gets shifted, towards the right. This is terminology which we use. Okay, this is overall the result of hysteresis loss. Hysteresis loss is an internal loss which will not appear to you on the first state, but will happen internally. What happens in that? The energy which was given in the deformation is not recovered back. From here, we have concluded that F is equal to 0.5 Newton. We have seen that the value of F, the rolling friction or the rolling friction force, is very less. So we do not include these forces whenever the body is accelerating. Whenever the body is performing the constant velocity motion, then in that case only we will discuss the rolling friction questions or rolling friction concept. Okay, in the next question we have seen about Lagrangian mechanics. Lagrangian mechanics, only thing you should know is the L is Lagrangian function. L is equal to kinetic energy minus potential energy, and this is the Lagrangian equation. This is a mathematical relation which is derived using higher mathematics, which is not into your syllabus. So only thing you need to know is this equation: d by dt, time derivative of partial derivative of Lagrangian function with respect to velocity minus partial derivative of Lagrangian function with respect to displacement is equal to 0. We can find the same results using various other methods, but this is also a method which can be useful in some difficult problems. Okay, and in last case we have seen that how this rod was kept on a smooth surface, and here the angular velocity, angular momentum and the linear momentum both remains conserved. Angular momentum and linear momentum both remains conserved. I hope this was helpful to you. If there is any suggestions and if there is any query regarding GATE exam preparation, you can suggest it. You can suggest us. Okay, thank you, Vijay. At quality@thegateacademy.com. Please do visit to our channel and see the various sessions are available to you. We keep on posting videos to help students. Okay. Thank you, everyone. Thank you.